Module 3 Operational Amplifiers and Applications. In this video, we are going to discuss about the basics of the op-amp, operational amplifier. And in the upcoming videos, we will discuss more about this operational amplifier, and also we will see how we can design the different circuit using this operational amplifier. As its name suggests, this operational amplifier is basically an amplifier, and the basic job of any amplifier is to amplify the input signal. The operational amplifiers are used primarily to perform mathematical operations such as addition, subtraction, integration, and differentiation. So the name operational op-amp. With the help of op-amp, the circuit design becomes very simple. Basically, this op-amp is versatile IC, and you will find this in so many applications like in audio amplifier, signal generator, signal filters, biomedical instrumentation, and in A to D conversion, ADC converter, and in the oscillator, etc. Now, today's op-amps are linear ICs. So it uses relatively low DC supply voltages, and it is reliable and inexpensive. Okay, and it's more compact, and amplified gain is very high. Okay, higher gain can be obtained by using op-amp. So these are the some advantages of op-amp, and it is easy to design. So now this is a circuit symbol of op-amp. Okay, it consists of two inputs and one output, and most of the amplifier consists of two power supply, positive and negative. Okay, but there are many op-amp ICs which runs on the single power supply. So here input terminal, which is marked by plus sign, is non-inverting input terminal, and input terminal, which is marked by minus sign, is inverting input terminal. It is a type of differential amplifier which amplifies the difference between two inputs. Let us say V1 and V2 are two inputs which is being applied to this op amp. Then the output voltage is proportional to the difference between two input signal. We can write V0 as V0 proportional to V2 minus V1. And if the gain of the amplifier is A, then the output voltage V0 is equal to A into V2 minus V1. Now, if the single input is applied to the amplifier and the other terminal is grounded, then at the output we will get gain A into V1 or A into V2 as the output. So here A is open loop gain. Is if there is no feedback from the output to the input side. Op amp is very high gain amplifier. Okay. The value of gain is in the range of 10 power 6 to 10 power 5 to 10 power 6. Okay, so now let us see the op amp input modes. The input signal modes are determined by the differential amplifier input stage of the op amp. So differential mode. In this mode, either one signal is applied to input with other input grounded. So this mode is single-ended differential mode. So now here, the signal, in this case, the signal is applied to the non-inverting plus non-inverting input with inverting input grounded. Okay, inverting input grounded. Here, a non-inverted amplified signal voltage appears at the output. And here in this case, where the signal is applied to the inverting input, okay, and with non-inverting terminal is grounded. Okay, so here a inverted amplified signal voltage appears at the output. So now two opposite polarity signals are applied to the inputs. Two opposite polarity signals are applied. See this, it's positive going signal and here it is a negative going signal. Okay, so this mode is called double-ended differential mode. So this mode can be represented by a single source connected between two inputs. Okay, so now, as we know that operational amplifier amplifies the difference between the two input signals, right? So we can write this expression Vd is equal to differential voltage Vd is equal to V2 minus V1. Now the output voltage V0 is equal to AD into Vd is equal to AD into V2 minus V1. So now here AD is called the differential gain, okay, and it is given by AD is equal to V0 divided by V0 divided by Vd. So this differential gain AD is also known as open loop voltage gain. So generally this differential gain is expressed in dB, 20 log 10 AD. So next, common mode. So in this mode, two signal voltages of the same phase, amplitude and frequency are applied to the inputs. That means two input signals are equal. So in this case, output voltage is 0. But when V1 equal to V2, when both the input signals are equal, then ideally the output must be 0. But practically the output voltage not only depends on the difference voltage, but also it depends on the average common level of the two inputs. Such common mode signal or common mode voltage VC, that is denoted as VC, is equal to V1 plus V2 divided by 2. So now, in this case, output voltage V0 is equal to AC into VC. So here AC is called common mode voltage gain and VC is called common mode voltage. So now the total output of a differential amplifier is given by V naught is equal to AD into VD plus AC into VC. So here AD is differential voltage gain and AC is common mode gain.